Planning. Before stepping into the field, planning is everything in surveying. It ensures accuracy, efficiency, and cost-effectiveness in every project. A well-planned survey sets the foundation for success. First, always double-check that all necessary instruments are prepared and in proper working condition. The right tools are essential for obtaining accurate results. The primary instruments used in this survey include the total station, range poles, wooden pegs, flags, Broughton compass, tripod, and prisms. Triangulation and trilateration. In triangulation, angles are measured and sides are computed using trigonometry. In trilateration, sides are measured directly in the field, and angles are computed from these measurements. The key difference between the two lies in how data is collected. In triangulation, angles determine the sides, while in trilateration, the sides determine the angles. Aside from this, the overall process remains the same, establishing triangulation stations. To begin, 6 triangulation stations are established: A, B, C, D, E, and F. The AGN 3097 marker, located at the flagpole oval, is designated as point A, where the instrument will be set up. Setting up the instrument. Fully extend and lock the tripod legs. Spread the tripod legs and position into the station A. Center the tripod head on the station, ensuring that the station point remains visible. Carefully remove the total station from its carrying case and attach the battery correctly. Secure the instrument onto the tripod and tighten the central screw. Power on the total station and activate the laser to center the instrument precisely over the point. Adjust the tripod legs, keeping one as a base while moving the other two, until the circular bubble vial is centered. Fine-tune the leveling using the 3 leveling foot screws until the bubble in the level vial is centered. Next, a Broughton compass is used to determine the direction of south, setting 0 degrees. The horizontal motion screw is then locked. Once the total station is powered on and the south direction is determined, the instrument's angle is zeroed using the offset function. The instrument is then rotated clockwise towards station B. Setting the prism and measurements. Note that both methods are measured simultaneously. For both triangulation and trilateration, the baseline between station A and B must be measured precisely, conducting 2 trials for accuracy. To proceed, we will now then measure the angle for triangulation and distance for triangulation. Clicking Escape, Distance, then Measurement. In triangulation, the azimuth angle from A to B is measured. In trilateration, the distance from A to B is measured. Moving forward, the instrument is sighted on station C and set to 0 to obtain the interior angle BAC while simultaneously measuring the distance A to C. The instrument is then rotated back to station B to obtain its interior angle, following the same measurement procedure. At station B, the instrument is set to 0 before sighting station D to measure the exterior angle. The instrument is rotated clockwise from station B to D, measuring both the exterior angle and distance A to D. The instrument is then set to 0 at station D and sighted on station C to obtain the interior angle DAC. Now we remove the instrument from the tripod and move to station B. Once these measurements are taken, The instrument is removed from station A and repositioned at station B. Continuing the process. The total station is set up at station B and 0 is set towards station A to measure the interior angle ABC. The instrument is sighted on station C and the angle ABC is measured. The distance B to C is also recorded. The instrument is set to 0 at station C to measure the exterior angle from C to A. From here, the entire process is repeated at all remaining stations, setting up instruments, measuring distances, and recording horizontal angles. Final steps. Once all necessary data has been collected, carefully remove the instrument from the tripod. Detach the battery from the total station and secure everything inside the carrying case. With precise measurements and well-executed survey, the collected data will be invaluable in mapping and analysis. Surveying isn't just about measuring, it's about accuracy, precision, and laying the groundwork for reliable data. In triangulation, we adjust observed angles to ensure the sum of interior angles at each station is 360 degrees, correcting discrepancies proportionally. Then, we adjust the triangle angles to total 180 degrees and use the law of sines to calculate unknown side lengths. Using these distances and azimuths, we compute the coordinates of each station through latitude, departure, and updating northing and easting values to ensure accuracy and consistency. In trilateration, we start by calculating the mean distance for each line, and then determine horizontal angles using the law of sines and law of cosines. After calculating latitude and departure for each station, we compute the northing and easting coordinates based on a reference station.